Sorry about that, guys. Stream seemed to cut out there for a minute. I think the internet died. So I'm just going to go and grab, so we've got 2 amplifiers that I got out for today's stream. Both of them are working fine, which is kind of frustrating. So I'm just going to pop downstairs. Refocus this a little bit. I'm just going to pop downstairs and grab some more. Something else to work on. Alright, here we go. We have a Vibe M21K, and this apparently has no sound. I believe that it works fine, as in Class D and everything. It just doesn't have any audio output, so this one has been intermittent with the audio output. So let's pop this off and have a look. So Henrik says, really like the last vlog type video. More of those videos, please. Oh wait, let me get my chat back up and running. Where is it? Here we go. Hang on a minute. Oh, I need to pop out chat. Pop out chat. There we go. Firefox. There we go. Sam over 2, what's going on? Yeah, I'm enjoying just making some chill vlog style videos. If you want to see what I've been up to recently, I have a second channel called Bear Clips. So head on over to Bear Clips, and that's just where I'm posting random sort of vlog style content. Okay, so let's get some power wires into this M21K and see why it has no audio. Sam, I have 615s on 3 amps, 2 subs per amp. Any suggestions on gain matching? 615s, 3 amps, 2 subs per amp. I'll have to think about that. No, this is not made in the UK. This is a Korean Xenon kind of full bridge attempt. They're absolutely terrible, these amps. They do make power, but they're massively overheat. They have, you know, this design of these is terrible. This one has been on fire previously. I recognise this board. But I don't think that this area over here that looks kind of janky has got anything to do with the no audio, because this is in the power supply. So let's just power it up and see what we got. Let's get some signal going in. And let's power up, see what's happening. Okay, we're building some rail voltage. Yep. Okay, Class D switching has initialized. Let's zoom out on the scope, and we have audio. Okay, so it is currently working, it would appear. What I'm going to do is put a sub across the terminals, because this is a full bridge amp, so we want to double check that, you know, both halves of the bridge are working, if you like. I think this one's been a bit intermittent, like sometimes it works, sometimes it doesn't, so I'm just going to power it on, leave it playing for a bit, and just see whether I can get it to cut out by like touching parts on the board, for example. Might have some vibration damage that's causing the signal to drop in and out. Okay, power up. Class D switching. And here we go, here's my little Sony X-Blood that we can use to confirm this is working. Okay, so we have good clean output just now. So what I'm going to do is just touch some things around the board to see if I can make this stop working by touching somewhere. Okay, let's play with the preamp switches on the side, for example. That's a bit crackly, that one. Okay, they're not causing it to cut out though. Let's try the potentiometers. Okay, that's alright. That's alright. Potentiometers seem fine. Let's give this a little whack with something non-conductive. Let's go for our wooden toothbrush. Okay, not seeing any dropouts in the audio signal at all yet, so I guess I'll let it run for a bit and see what happens. 12 volts, 14 volts, maybe it needs high voltage to cut out. How's it going, Zach? Let me just check my message from this guy, see what he's saying. Alright, he said just try the amp again, hoping that when it laughed at me, not sure what to do. Hey buddy, so just put the amp on the bench and currently it's working, comma. How often does it work before it cuts out? Question mark. Maybe I should install this one in the van, just so I can kind of test it for a while. No, same outfit. Didn't change outfit. Let's have a little look with the thermal imager, just see if anything's getting hot in here. Okay, it's all pretty normal. Pretty normal looking heat from everywhere so far. Yeah, not seeing any issues there. Different cap and you took a jumper off. Nope. Nope, exactly the same outfit. I used a different thumbnail. The thumbnails I use are just from like old before, so. This one is working fine for me as well. So this one's going to have to be an endurance test amp. So again, not really one that I can sit here and repair on stream. This is hilarious. Every single time I jump on stream, so we've had Hertz Mini 4-channel, fine. MD8K 4-channel, MD8K mono, fine. M21K, fine. Alright. Let's break something so we can fix it. Yeah, exactly. I do have the T amp, which I could continue with, but okay, let's just power this off and power it back on again. If the gain knob was crunchy, what would you troubleshoot? I'd just replace the gain knob. If the gain knob is crunchy, then the gain knob is bad. So I'm just kind of looking at and just kind of noticing this amplifier. So the only reasons that you have no audio with this amplifier, okay, is a few reasons. You can have the relays not engaging. Okay, that's not true. The relays do engage. The customer checked that when it had no audio for him, the relays were engaging, so that's fine. We can have no Class D switching, which I would be surprised at. I can't really see any reason why we would have no Class D switching when this all works absolutely fine just here. There's another circuit in the preamplifier, which is a muting circuit in the preamplifier. So you'll notice that if we turn the amplifier off and turn the amplifier on again, okay, so we turn the amplifier on now, okay, the amplifier comes on, the relays engage, and then the sub comes to life. And that is when the muting circuit in the preamp disengages and allows signal through. So I wonder whether there is an intermittent issue with the muting circuit in the preamp somewhere. But obviously where it's working at the moment, I can't really diagnose that. The best I can really do is just give everything a good old clean with the isopropyl alcohol contact cleaner. Possible that there is some condensation residue on the back of the board that is causing there to, you know, the muting circuit to kind of be intermittent. So, alright, let's pull this one off the bench, and yeah, I'll have to do some sort of endurance testing, just maybe give this a clean and whatever, but yeah, from what I can see, that's working just fine at the moment. I'll wait for the customer to get back to me. Let me know how often it cuts out or whatever. So, let's talk about Boom or Bust Season 2. So obviously I've got the PT Cruiser, which is the test cabin that we're going to use. So I've been doing some testing with it, and because obviously it's an RC car, compared to a real full-size car, the cabin in that little model is not sealed very well to the outside world, okay, and it's, you know, it's very gappy inside. So obviously with a real car, and also with my first Season 1 test cabin, the cabin itself is pretty well sealed to the outside world. You know, it doesn't really have any leaks throughout the cabin, outside, etc. The only leak that you have in a real life cabin is going to be like the vent, the kind of air pressure vent usually at the back of the car, behind the trim. Everything else is pretty airtight. So what I need to do with the PT Cruiser model is I need to go through, I need to fully dismantle it, and I need to seal all of the gaps, all of the bits between the trim and everything, so that the cabin is pretty airtight to the outside world. Because at the moment, when I tested this with the benchmark Aeroport box for Season 1, in the test cabin that we used for Season 1, we got 145 dB, okay, which is obviously pretty loud. The test cabin for Season 1 was more like an extreme class cabin though. It was absolutely like reflective as hell. It was like basically a concrete box when you scaled it up. So that's not super realistic, but it was very loud. So I'm thinking a single 12 in a regular car with no sort of crazy strengthening or deadening or anything, it's probably going to be like a 138, something like that. So testing it in the cabin as it stands in the Cruiser, 115 dB. So we are a long way off, and that is just because the thing just has, it's not sealed. It's not a sealed cabin. It just, all the pressure just pisses off to the outside world. So we need to seal it up good and proper before we start Season 2. Yes. So that's going to be a little mission for me to do. Right, another fully functional amp. Let me go and grab another one from downstairs then, and see if we can find something that's actually broken today. Alright, this one definitely should be broken. Customer states on this one, this is a JD1000 from JL Audio. Customer states no power, so hopefully there is in fact no power and we can actually get a repair on the go. Okay, so what is this then? This is the JD1001 by the looks of it. Is that right? Is it mono? Yeah. Okay, so we have power supply transformer, power supply MOSFETs probably under here. We have, oh no, sorry, hang on, probably, right, power supply FETs are going to be under here, okay. Power supply FETs under here on the back of the board. We have rectifiers maybe, or voltage regulators here. Rectifiers here, voltage regulators here, pre-amplifier, all op amps and stuff. We have class D circuitry and stuff over here. Output MOSFETs under, oh, this is diode D, oh no, yeah, output MOSFETs under here. Full bridge circuit with 2 output inductors and terminals. Okay, let's just check for shorts across the power supply FETs real quick. So they're going to be these guys just here. Yeah, that's fine. Ah, hang on a minute. We have a short there and there. Yeah, okay. Yeah, okay, dead power supply. What about the output side? Output FETs are here. Uh-oh, full rebuild. Dead outputs as well. Lovely jubbly. We went from nothing being broken to everything being broken. That's what we like. Okay, well let's strip this down then, shall we? 'Cause we need to get to the MOSFETs on the back and stuff on the underneath. I don't think I've worked on one of these exact boards before. JD1000. I worked on the JX, the XD, the Slash. Don't think I've done. So that customer with the Vibe, the M21K, said that he installed it, set the gains, and then came back to it a week later and there was nothing. And he tried a few more occasions and there was still nothing. And then he just sent it to me. So I guess what I'll have to do is install it somewhere in the workshop or in the van or something like that, and just keep an eye on it and just, you know, use it until it stops playing, and then I can diagnose it once it's not working. What's up? Sirius, how's it going, man? I have a fun amp, it doesn't like high side FETs. Some of them heat up. The heating of FETs changes based on the FETs I install. What amp is it? And what are the MOSFET models? So if the heating changes with where you put the FETs or what FETs you've got, then the heating is as a result of cross conduction due to slight differences, ever so slightly tiny differences in VT, MOSFET turn on threshold. So you're on the edge of cross conduction there, and there is a solution to that. Okay, what's stopping this from coming out? What's stopping you from coming out? It's like it's loose, but there's something caught underneath, so I guess we're going to have to take this end plate off as well, and lift it up from the other side. It's probably because there's MOSFETs and stuff on the underside, so there'll be raised bits for the FETs to clamp to. Oh, 38N20. Had 31N20 before. Yeah, so you could have differences in VT. Check that there are 4148 diodes in parallel with the gate resistors. That can help them turn off quicker, get rid of the cross conduction. There we go. So it was just caught on these little raised bits. Okay. Oh damn! We've got some absolutely cooked traces here that have acted like fuses. Acted like a fuse under here, so that's pretty fun. You'll have to see that. I mean, it's kind of good in a way because it saved, you know, other stuff burning. These traces just went, see ya! So, what FETs is this amp using in the output section? I've never worked on one of these before, so it'd be cool to see. So we have, that is very stuck to the thermal pad. Very stuck to the thermal pad. In fact, it's taking the thermal pad with it, so we cannot see. Right, you are IRFB 4410Z. 4410Z. Okay, cool. I think I've got some of those in stock. Probably going to need new thermal pad now because it's going to take the middle of the pad up with these FETs, isn't it? I could probably just flip it over. The heat isn't. Yeah, the heat doesn't need to transfer to the top of the board here. This pad is just acting like a spacer, really. So, yeah, we could just pull that and flip it around, and it would work just fine. Okay, and what power supply FETs are we using here? We're using good old 3205s. You'd love to see it. You love to see it. What's up, Mike? How's it going, my friend? So let's chop these out. What's the drive circuit on the output side? Drive circuit on the output side, we've got some 2101s being the final drive buffer. I wonder if they survived. Yeah, so if you already have 4148s, it might just be that your FETs just have different different VT values, or the drive circuit isn't really optimized for running those. Right, let me ask some of you guys real quick. Is anyone here in the live chat currently experienced with Comfy UI and running models on local hardware? If you are, let me know. Love to grab some advice. No, it's not a Linux thing. Took a minute to realise you were picking out cut legs. Yep, we chopped them guys out already, bro. So that was the power supply side we just did. Now I'm just quickly doing the output side, and then we'll check the drive circuit. Alright, so we've got some traces to repair on the power supply side. I just want to check the drive circuit for the power supply as well. It looks like we've got 47 ohm gates, but the way that this amp failed seemed pretty quick. So I'm hoping that the drive circuit survived. So we got, I know it says 72, but that's just because my multimeter is in diode mode, and 72 means 47 ohms. So that's fine there. If the gate resistors are okay, almost guaranteed that the drivers are okay. Now this one here's a little low, 70. So that's a bit worrying. And this one over here, no, that one. So that one there, that gate resistor, that's reading 46 point. Well, it's a bit lower than that because we've got test lead resistance. So that gate resistor is reading a bit low. It looks visually fine. Very strange. Usually resistors will go high when they fail. Not always, but almost every time. So the drivers themselves are these guys. Let's just do a quick diode mode check to make sure that they're not obviously shorted or anything like that. These are reading just fine. So it's possible that that resistor was just a little bit wacky tolerance from the factory. You know, 0.8 of an ohm difference isn't going to affect anything at all. So we're going to assume that no current made its way down the gate resistors to the drivers. The drivers there for the power supply side are almost certainly absolutely fine. However, if we take a peek at the output section, I've just noticed we do have a damaged surface mount resistor, which is never a good sign. So what's that for? Is that for bootstrap? It's next to a big diode, so it could be for bootstrap purposes. We've got another one over here that looks like it's the same part of the circuit. We've got a diode here and a resistor. Oh, we've got another blown resistor there as well. A few blown surface mounts up on this side. So this blown resistor is almost certainly going to be the same value as this blown resistor, and this is a something R75. Sorry if my head gets in the way, I just need to really have a look at this. Let's have a look at it under the microscope. It's kind of been burned, so it's quite hard to read. Let's turn the microscope on and have a look. Okay, yeah, it looks like it's a 4R75. 4R75. What a strange value. And that burnt one next to it is a 10R. This one, 10R, 4R75. I wonder if a 4R7 will do. why 4R75? Maybe I'll just replace both of them with 4R7. And then we've got, yeah, like I say, this one here is going to be a 4R75 as well. And we've got another 10R over here that's blown there as well. So yeah, a few bits not looking so healthy over here. I suspect the drivers, the two 101s, are probably bad. We'll see what the resistors are in line with to determine whether they're likely bad without actually having to test them. So because we know those resistors are bad, let's just get those out of the circuit first, and we can test other parts of the circuit around them. Is that one gone? Is that one gone? Reflow that pad a little bit. Is that one gone? And over here. Cool. Okay, cool. Any other resistors obviously burnt? Not that I can see at the moment. Doesn't look like. Okay, cool. So let's grab the multimeter, diode mode, and let's go over some of these semiconductor parts over here by the output section and see what we have going on. So let's check these, probably bootstrap diodes. We're looking for connection. Yeah, we've got 463 that way round, that's good. 460 that way round, yeah, so these diodes are fine. Let's check these tiny little ones just here. Tiny little glass diodes. What are we saying? That one there, that's 559, that's probably good. Let's read this one. 324. Ah, that's a bit of a different reading, that one. How about the other way around? Okay, so we have the same part of the circuit, just one on each side of the bridge, and we have different readings. The diodes, these are probably fine because they're not reading the same both ways, but we probably have dead driver. Okay, we have a diode over here that's 62 ohms both ways. That's not promising unless it's in line with the gate resistor. Okay, no, it's probably just in series with in parallel with the gate resistor, so that's fine. Those are okay. 33 ohms. Okay, so we have a failed diode here potentially. And what are these? Let's just snip that there. Okay, so it's not the diode that's bad. Something else in the circuit, probably. 229. Okay, so that diode's probably okay. So there's something else in the circuit there, probably the drive IC. So let's remove the drive IC. Probably both drivers, because we had burnt resistors on both sides. So it's what likely happened was one drive IC failed and spiked back and killed the other. So let's almost certainly remove this driver here. This is the 2101 for this side, and yeah, we've got a whole bunch of shorted pins together. Yeah, loads and loads of shorted pins, so that is cooked. So let's get that out of here. Now, do I have any 2101s? Don't know if I do. Bit of a random one. Don't think I do. (2011). If I do, they'll be in this little drawer here. Ah, there we go. Okay, there's a 2101. So I've got one there. So I have used them before. And there is another 2101. Okay, so I do have a pair of 2101s here that I could drop in. That's pretty cool. Wait, is this one a little bit hard to read? 2001. Alright. So that should be heated up now. Let's get this driver out of here. Okay, so with that removed, let's just double check that we've lost the short on this diode. Yes, we have. All the shorts on these pins. Yep. Yep. So let's just check this other driver over this side. What are we saying? Are you alright or are you bad as well? I think you might be okay. Even though there was some blown resistors for you, you might be just okay. So I think we're going to change you just for good measure anyway. Man, I tell you what, right, I'm going to leave it in place for now. If it works fine, I'm still going to change it, but I'm going to put it in my, like, you know, salvaged parts drawer as a working but unknown condition. You know, unknown how much life it's got left. So I want to put two new drivers in here anyway, just because we had some blown resistors over that side. But I want to see if it works first before I remove it. So let's drop this new driver in here. Make sure we get the orientation correct. Looking good. Okay, let's let that cool down for a minute. Please read the listing description and follow the instructions. Thanks. Alright, cool. Check resistances and diode mode rings over here. So we've got 333. Okay, we do still have some differences. Oh no, looks actually fine. Looks like it's just because this one is hot. Alright, so I'm going to leave the output section alone just now. I'm going to put some brand new FETs in the power supply side. Okay. So let's grab some power supply FETA rubies. Now I've got two choices of MOSFET to use here. Let's just see what one's going to be better. I've got 033NO4NS, or I've got E. So these are 113 amp. Okay, so these are going to be better. Lovely stuff.